Why seatbelts save lives? The physics behind road safety.
For my part, I will introduce to you guys Newton's first law. This law is introduced by Isaac Newton and also known as the law of inertia. Wow. Another common examples of inertia is car collisions. I'll show you guys a video of car collision. Before a crash occurs, both the car and the passengers are moving at the same speed. When the car suddenly stops after hitting an obstacle, the passengers' bodies continue moving forward. This happens because of inertia. The passengers' bodies want to keep moving even though the car has stopped. This is where seatbelts become very important. A seatbelt provides the external force needed to stop the passengers safely. Instead of being thrown forward into the dashboard or windshield, the seatbelts hold the passenger in place and slows them down more gradually. This greatly reduces the risk of serious injury. So, what will happen without a seatbelt? Without a seatbelt, the passengers may continue moving forward at the vehicle's original speed, which can result in severe injuries or even a death. Therefore, wearing a seatbelt is one of the most important safety measures when traveling in a vehicle. So, I will show you guys a comparison between wearing a seatbelt and without wearing a seatbelt while driving a car. Newton's first law can also be observed in everyday life. For example, raindrops spawn off when a wet umbrella is rotated and suddenly stop. Raindrops on an umbrella are in motion as the umbrella rotates. When the umbrella stops rotating, the inertia of the raindrops causes the raindrops to continue in motion and leave the surface of the umbrella. And the last example is Earth moving around the sun. People on Earth are moving together with the Earth as it travels around the sun. The Earth moves at a very high speed, but we do not feel these motions because everything around us moves with the Earth. When the Earth moves around the sun, the inertia of the objects on Earth keep them moving together with the planet. Since we, the atmosphere, buildings, and oceans are all moving at the same speed and in the same directions, we do not notice the motions. Earth's gravity also helps keep us firmly on the surface.
And now I'm going to talk about the next point, which is force reduction during crashes.
Firstly, crashes involve sudden changes in motion. During a collision, the car can stop within a fraction of a second, but the passengers inside continue moving forward due to inertia. Because the body is forced to stop so quickly, a large force is produced. This is why car crashes can cause serious injuries. Second, seatbelts increase stopping time. When a crash occurs, the seatbelt holds the passenger and allows them to slow down more gradually. Instead of stopping instantly, the body takes a slightly longer time to come to a complete stop. This increase in stopping time helps reduce the force experienced by the passenger. Third, reduced force means reduced injury. Since the seatbelt lowers the impact force, less stress is placed on the body. Important areas such as the head, the neck, chest, and internal organs are better protected. As a result, the risk of severe injuries is significantly reduced. What am I showing you right now is a video simulation of a car crash, which shows that there are 4 people in the car and 3 of them are wearing their seatbelts while 1 of them isn't. So let's see what happens when a car crash happens to them. So, as you can see, in this simulation, the passengers wearing seatbelts experience a smaller force because the seatbelts increase their stopping time, which is why they experience less injuries. The passenger without a seatbelt stops suddenly upon hitting the windshield, resulting in a much greater force. This illustrates the physics behind why seatbelts reduce injuries and save lives. So, don't forget to wear your seatbelt.
I'll be talking about impulse and collision time, 2 important concepts in physics that explain why safety features like seatbelt and airbags are so effective. Impulse is the change in momentum during a collision. Momentum itself is mass multiplied by velocity, and when either mass or velocity changes, momentum changes too. Wow. The formula is impulse equals force multiplied by time, and it's also equal to the change in momentum. This means impulse connects the force acting on the end object with the time that force is applied. Collision time importance. Now, let's focus on collision time. Collision time is the duration of the impact of the time it takes for an object or person to come to rest during a collision. If the collision time is very short, the force experienced is very large. That's why sudden stop can be so dangerous. But if we can increase the collision time, the force becomes smaller even though the change in momentum is the same. Seatbelt examples. Take a car accident as an example. Without a seatbelt, the passenger's body stops almost instantly when hitting the dashboard. The collision time is extremely short, so the force is very high. With a seatbelt, the passenger is restrained more gradually. This increases the stopping time, which reduces the force acting on the body. So, seatbelt don't change the fact that the car stops, but they make the stopping process safer by spreading out the impact. Other safety features, such as airbag work in a similar way. They inflate to cushion the passengers, increasing the time it takes to stop and reducing the force. Crumple zone in a car are also designed to absorb energy and lengthen collision time. Instead of the car stopping suddenly, a part of the car deformed to protect the passengers. Even in sports, helmets and padding use the same principle. They increase stopping time when hit, lowering the force on the body. So, the key takeaway is, impulse is the change in momentum and increasing collision time, reduce the force experience. That's why seatbelt, airbag, and crumple zone are essential safety features. They don't prevent collision, but they make collision much less harmful.
Momentum is the quantity of motion of an object. It is defined as the product of an object's mass and velocity. This means an object must be moving to have momentum. The SI unit of momentum is kilogram meter per second or kg/ms. Momentum depends on two factors, mass and velocity. An object with a greater mass has greater momentum if it moves at the same speed as a lighter object. Likewise, an object moving at a higher velocity has greater momentum than the same object moving more slowly. Therefore, increasing either mass or velocity increases momentum.
Have you ever wondered why a football tackle feels so powerful? Or why does a moving car take longer to stop than a bike? The answer lies in momentum. Momentum is mass times velocity. In simple terms, more mass means more momentum. More speed means more momentum. Let's put this to the test. A small push gives the ball little momentum, but a strong kick sends it flying. More velocity equals more momentum. Who moves faster? The heavier student or the lighter student? The lighter student. Less mass means easier acceleration, but the heavier one has more momentum. A fastball has more momentum than a slow toss, making it harder to stop. What did we learn? More mass means more momentum. More speed means more momentum. Momentum is conserved in a system without outside forces. Momentum is everywhere, from sports to car crashes. Now, it's your turn. Test it yourself and see physics in action.
Momentum is a vector quantity, which means it has both magnitude and direction. The direction of momentum is always the same as the direction in which the object is moving. Whenever an object's velocity changes, its momentum also changes. Momentum is important because it helps us understand what happens during collisions. It is widely used in transportation, sports, and engineering. Engineers use the concept of momentum to design several vehicles and protective equipment, while athletes use it to improve performance in sports.
For my part, I will talk about energy absorption and distribution. I will explain three main points, which is kinetic energy of moving passengers, impact force distribution by seatbelts, and injury prevention and passenger safety. First, let's discuss the kinetic energy of moving passengers. When a vehicle is moving, all passengers inside the vehicle are moving as well. Any object in motion possesses kinetic energy. During a collision, this kinetic energy must be reduced safely. If it is not controlled properly, passengers may suffer serious injuries. This is why safety devices such as seatbelts are important in vehicles. Next, let's look at how seatbelts distribute impact forces. During a crash, a large force acts on the passenger's body. Seatbelts help spread this force across stronger parts of the body such as the chest, shoulders, and pelvis. By distributing the force over a large area, the risk of injury to any one body part is reduced. This makes seatbelts an effective safety feature during collisions. Now, let's discuss how seatbelts help prevent injuries and improve passenger safety. During a collision, passengers may be thrown forward due to the sudden stop of the vehicle. Without a seatbelt, they could hit the dashboard, steering wheel, or windshield, which may cause serious injuries. Seatbelts help keep passengers securely in their seats and prevent excessive movement during a crash. As a result, the risk of injuries to vulnerable body parts such as the head, neck, and chest is greatly reduced. To better understand how seatbelts protect passengers during a collision, let's watch a short crash test demonstration. As shown in the video, the passenger without a seatbelt is thrown forward when the collision occurs. This can cause severe injuries from hitting the steering wheel, dashboard, and windshield. In contrast, the passenger wearing a seatbelt remains securely in the seat. The seatbelt restrains the body and helps reduce the risk of serious injuries, especially to the head, neck, and chest. This demonstrates how seatbelts play a crucial role in protecting passengers during a collision. In conclusion, seatbelts play an important role in keeping passengers safe during a collision. As explained in this presentation, physics concepts such as inertia, momentum, impulse, force, and energy help us understand how seatbelts work. By reducing impact forces and protecting the body during a crash, seatbelts can greatly reduce the risk of serious injuries. Therefore, wearing a seatbelt is a simple action that can help save lives.